Okay, so what if you could undo any mistake in your code instantly and never lose a single hour of work again? By the end of this video, you'll actually understand Git, not just memorize commands. Let's build a real project together and just learn it step by step. So, Git is a version control system. In plain English, it's basically a time machine for your code. Every time you save your work in Git, you're taking a snapshot of your whole project, a checkpoint you can jump right back to anytime. Make 10 changes, then realize, oh yeah, yesterday's version was actually better. You just travel back. Nothing's ever really lost.
And here's the thing. Git isn't just for you. It's how whole teams work on the same code without stepping all over each other. All right, let me show you exactly how by building something real. So here's our project, a folder called Mastering Git with two files, hello.js and readme.md. Right now, Git isn't even watching it yet. We turn this folder into a Git repository with one little command, git init. And boom, that just created a hidden .git folder, the brain of the whole thing. From here on, it tracks every single change.
All right, let's check the status. Git status shows Git can see our two files, but they're untracked. Meaning Git knows they exist, it's just not saving them yet. Okay, so to save a snapshot, it's really just two steps. First one, staging. We pick which changes go in. Git add dot. Well, that stages everything. Think of staging like a box you're packing before you ship it, right? You decide exactly what goes inside. Second step, we commit. We kind of seal the box and slap a label on it. Git commit -m, then a little message describing what changed. And there it is, our very first checkpoint. On the graph, that's a commit, a permanent snapshot with its own unique ID, an author, and a date.
Now, here's a detail most people totally miss. A commit doesn't just save the files that changed, it captures the exact state of your whole project at that instant, forever. Okay, so Git and GitHub, they are not the same thing. And honestly, this trips up almost everyone. So let's clear it up. Git lives on your computer. It's the tool doing the tracking completely offline. GitHub, though, that's a website, a place in the cloud to store your repo and share it with your team. So Git's the engine, and GitHub's the garage, where everyone parks and builds together. To connect them, we add a remote, just a link to the GitHub repo, and then we push our commits up. Refresh GitHub, and there it is! Our project, live in the cloud, backed up and shareable. Okay, now this is Git's real superpower, branches. So say we want to add a login page. We do not build it on main, the version that has to keep working. Instead, we branch off. Git switch-c feature-login, that creates a new branch and jumps you onto it, a safe, separate copy. On this branch, we add our login code and commit it. And watch, main? Completely untouched. Then, once the feature works, we bring it home, switch back to main, then merge. And the two timelines just become one. Quick deeper tip. Branches in Git are cheap and instant. That's exactly why pros spin up a fresh branch for every feature and every bug fix. No exceptions. Now, on a team, you don't just merge into main yourself. You open a pull request. It's basically a proposal on GitHub that says, hey, here are my changes, please review them. Your teammates comment, maybe request changes, then approve. And only then does it merge into main for everyone. That's how real projects ship safely. But what if two people change the same line? Adrian edits readme.md, and so does John. Now Git can't decide, and that's a merge conflict.
Don't panic, though. This is totally normal. Git just marks the clashing lines with these markers. You pick what stays, delete the markers, commit the fix. Done. Okay, now the part most tutorials just skip. Undoing mistakes. Git's got a different tool for each situation, and honestly, knowing which is which, that's a superpower. So you edited hello.js, but you haven't saved a snapshot yet, and you want the old version back? Git restore hello.js. That throws your changes away and brings back the last commit. Staged a file by accident? No problem. Git restore -- staged unstages it. Your changes stay. They're just, taken back out of the box.
What if you committed a bad change and it's already shared with the team?
Okay, don't rewrite history.
Git revert creates a new commit that cleanly undoes the old one. Safe for everyone. Now, if you're working alone and you want to truly rewind, Git reset moves your branch back. Reset soft keeps your work, but reset hard, that deletes it. So treat hard like a loaded gun. Want to see the project exactly as it was at some old commit? Just copy its ID and Git checkout it. Boom! You're viewing the past.
Git calls this a detached head.
You're visiting, not living there. To get back to the present, Git switch main. And to bounce back to the branch you were just on, Git switch with a dash. All right, 2 more tools you'll reach for constantly. First, stash. So you've got half-done work, but you need to switch branches right now? Git stash tucks it away, and Git stash pop brings it right back later. And then there's the .gitignore file. It just tells Git which files to never track, like your secrets or that giant node modules folder nobody wants in there. So that's Git and GitHub, end-to-end on one real project. Commits to save, branches and pull requests to collaborate, restore, revert, reset to undo, checkout to time travel, and a graph that remembers all of it. Master these, and honestly, you'll never lose your work again. If this finally made Git click for you, do me a favor, subscribe. New videos every week. And next up, we go a little deeper. How the pros write commit messages that actually tell a story. This is Codexium, your gateway to the future of coding. See you there.